Hello, my dear student. I'm Mr. Kitwala from Educare TZ. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our discussion on our topic of rotation of a rigid body for our subtopic of the center of mass. So before we proceed with our discussion here, we are supposed to remember where we ended on the last session. So my dear student, on the last session, we tried to see, on the last session, we tried to discuss about the vectors, of the body, of the center of the body, and we tried to see that the vector must be equals to the summation around the two dimensions. Means must be equals to the summation of m, must be equals to mass 1 times vector r1, vector of r1, then we add it by mass 2 times the vector r2, then we divide by the summation of their masses. And we looked about the two particles. That imagine we have the body, and that body contains their particles. There are two particles. So for the two particles, we try to demonstrate the formula of obtaining the center of the body. So my dear student, today here we are going to see some examples related with what we tried to see on the last session. So we have our example number 4.1. This is the example number 1 on our 4C topic for our book of the TIE. It means Tanzania Institute of Education. This is our first example for this topic here. So two bodies, our question is said that two bodies of masses 0.8 kilogram and also 1.2 kilogram are located at this coordinate. It means are located at the coordinate 1, -2 and at the coordinate -3, 4 respectively. Find the coordinate of the center of the mass of the system. That my dear student, we have our body, and that body contains their particle, contain two particles, as we try to see. Each particle have its own masses. The first particle have the mass of 0.8 kilogram, and involve it is coordinate, it is own distance along to the x-axis and also to the y-axis. It involve the coordinate of 1, -2. While the second particle of the body containing its own masses, which is equal to 1.2 kilogram, and also having their coordinate, which is -3.4. So my dear student, these particles are joined together or are connected together. If they are connected together, they form the resultant from the original. It means RCM. That is what we are going to see. But our question here needs us to find the coordinate of the center of mass of the system. Tumeambiwa tuweze kutafuta ile coordinate of the center of the mass of the system. Sasa coordinate yetu hizi center of mass of the system pale kwenye center hizo masses mbili zilizobini displaced at the center distance, kwa center yake pale coordinate zake zilikuwa ni ngapi? Is what we are supposed to go and find it into our equation here. First of all, we are supposed to understand our question, my dear student, and after that it is very important to summarize the data, the data that we have into our equation. So on our equation here we have the masses. We have mass 1 and also we have mass 2, and they also represented their particles. Also we have the coordinate. It means the coordinate 1 and also the coordinate 2. On the coordinate 1 here, we have x1, y1. This x1 equals to 1, and also x2 is equal to -2. While the coordinate 2 here having the mass 2, having their coordinate, means having the x2 and also y2 as we try to observe. So after there, from equation 4.3 and 4.4. Now let us recall our equations. We should recall the equation number 4.3 and also 4.2. 4.3 and also 4.4. Our equation 4.3, my dear student, give us the formula related to the x-axis. Lakini kwenye formula number 4.4, our equation give us related to the y-axis, kwenye coordinate ya y-axis. So let us start with the coordinate number let us start with the along the axis to the x direction. So along to the x here, we should say that the x the coordinate along to the x kwenye center of the body along to the x must be equal to m1. It means must be equal to the summation from I from I equal to 1 up to n up to 2, n I equal to 2. Or mi times x or mi times xi, lakini divided by summation of from I equal to 1 mpaka I equals to n. Lakini n tumeshapewa ni sawa na 2 hapo kwa sababu tuna particle mbili. A summation of the mass 1 as we try to observe here. So my lovely student here, because we have the two particles now, the x at the center of the body or the center of mass must be equals to the mass 1 times the x1, the coordinate or x1. Then we add it by the mass 2 times the x2. We divide it by the mass 1 plus mass 2. This we can divide it by the mass 1 plus the mass 2. But from our question we have our value. Kwamba kwenye swali letu tumepewa zile data zetu, kwa hiyo tunatakiwa sasa substitute zile data ambazo tumepewa kwenye swali letu into our equation here. Mass 1 tumepewa ni sawa na 0.9, lakini mass 2 tumepewa ni sawa na 1.2, lakini x1 ni sawa na 1, x2 ni sawa na -3. Kwa hiyo tutachukua zile values zetu, tutaweza kuzisubstitute. Tukisubstitute palipo na mass 1 tutaweka 0.8 kg times x1 ambayo ni 1 times 1. Then we add by 1.2 ambao yule ni mass 2. We times by the x2 ambao ni sawa na -3. We divide by the summation of their masses. It means 0.9 kg if we add by 1.2 kg. If we simplify, my dear student, the scion-t, because it is found at the top and also at the below here, it may cancel out, or zile scion-t zita cancel out. Mwisho wa siku tutapata yule coordinate, it means the center of mass along to the x-axis must be equals to the -1.4. So after there, my dear student, let us go and see along to the y-axis. Tukaangalia coordinate za y-axis. So for the y-axis, it is similar similar with the x-axis. Now we should say that along to the y-axis we have demonstrated the formula related with the y-axis, which is the equation number 4.4. The equation number 4 on our topic number 4. That is what we tried to demonstrate there. So after there here, my dear student, we should recall our formula. Lakini kuna summation wa mi divided by summation of mi. Kumbuka aya inaanzia 1 mpaka n, but here we have the two particles. Kwa n atakuwa ni sawa na 2. Hivyo tutakuwa na mass 2 pamoja na distance 2. It means y1 pamoja na y2. Therefore, my dear student, our formula should be the center of mass along to the y-axis must be equals to mass 1 times y1 if we add by the mass 2 times the y2 divided by the summation of the masses. It means mass 1 plus the mass 2. So after this, my dear student, we are supposed to summarize our given values. Into our formula we have the mass 1. Mass 1 tumeshapewa ni sawasawa ni sawasawa na 0.9. We should put mass 1 is equal to 0.8 kg, and also multiply it by the y1, which is equal to -2. If we add by the mass 2, which is equal to 1.2 kg, times the mass the distance 2, ambao ni sawasawa the y2, which is equal to 4, divided by 0.8 kg plus the 1.2 kg. So finally, we are supposed to take our calculator, my dear. So you have to take your calculator and substitute this value. Utachukua ile calculator yako. Baada ya kuchukua ile calculator, utasubstitute zile value ulizopewa, na baada ya hapo, baada ya kusubstitute zile value ulizopewa, utapata sasa kumbe this center of mass along to the y-axis must be equal to 1.6. This is our coordinate. Lakini kwenye coordinate wa x tulipata -1.4 while here is 1.6. Now after getting here, we are supposed to conclude by saying that the coordinate of the center of mass of the system are here. Kwa tutaweza sasa conclude kulingana na swali tulivyokuwa tumeulizwa. Here we was asked to find the coordinate of the center of mass of the system. The coordinate of the center of mass of the system. Now we should conclude by following the way we have been asked into our equation. We can conclude by saying that therefore the coordinate of the center of mass, the coordinate of the center of mass of the system are -1.6, 1.6. This should be our answer on this question. So after that, let us look for another example. The example number 2 on our fourth topic here. So our example said that two boats of mass 100 gram and also 300 gram have the position vector 2.2i plus 5j plus 13k and -6i plus 4j. Then we minus it by this 2k. This is what we have been given into our equations. That we have the two masses, we have the particles, and we have the body, and that's the body involved their particles. It contains the particle 1 and also the particle 2. The particle 1 having the mass of 100 gram, but it have their position vector, which is 2i plus 5j plus 13k. But at the particle 2, the body containing the mass 2, which is equal to 3 kg, and also the position vector of -6i plus 4j, we minus it by the 2k respectively, as we try to see here. So Roman A here, we are supposed to find the position vector of the center of the mass. What is the position vector of the center of the mass? That is what we have been asked on our question here. But on Roman B, my dear student, we have been asked to find the distance of the center of the center of mass from the origin. Ile distance of the center of the mass from the origin, kwa sababu zile particles zetu zilikuwa zimebini placed katika two coordinate, means along to the y axis and also to the x axis. Sasa tunataka ile kwa sababu zile particles zilikuwa zimeshabini connected together. Now we are supposed to find the distance. It means the distance of the center of the masses from the origin. Kutoka kwenye origin mpaka pale kwenye ile point ambayo inaziunganisha zile masses. That is what we are supposed to find on our question here. So first of all, we are supposed to summarize our given values into our equation. In our equation here, we have the mass 1, the mass of the particle 1, which have the position vector. Kwa hiyo tuna mass 1 ambayo ni sawa na 100 gram, na pia tuna mass 2 ambayo ni sawa na 300 gram. Pia tuna zile position vectors. Sasa tunatakiwa tuweze kutafuta ile position vector of the center of masses atakuwa ni ngapi. So my lovely student here, let us record the question number 4.5 and also the question number 4.6. As I told you that these examples here give us the overview for what we tried to see on our discussion, our last session. Kile tulichokisoma sasa tunapima kwamba je, maswali yako ambayo yanaweza yakaja ni maswali ya nature gani? Ndio ya namna hii swali letu inataka ndio inatupima swali letu. So my dear student, Roman A, we are supposed to find the center of the masses. How can we find the center of the masses? So let us record the question number 4.5. We said that the vector R of the center of the masses must be equals to the mass 1 times the vector of R1. Then we add it by mass 2 times the vector of R2. Then we divide it by the mass 1 plus the mass 2. But we should substitute our given value. Kwa tunachotakiwa pale tusubstitute zile data tulizopewa kwenye swali letu, tutaweza kuzisubstitute pale, kwa sababu tunazo kwamba huyu vector 1 tumeshapewa pale kwenye swali letu, na pia vector wa R2 tumeshapewa kwenye swali letu. Kwa tunachotakiwa ni kuweza kusubstitute. Tutasubstitute sasa palipo na masi ni sawa na 100 gram bracket. Then we add by the mass 2 ambayo tunao ni sawa na 300 gram times the R2, the vector of R2 that we have been given into our equation. So after there we divide by the summation of their masses. The mass 1 ambayo ni 100 gram, then we add by the mass 2 ambayo ni sawa na 300 gram. After there, my dear student, we should simplify. Kwa tunachotakiwa hapa ni kuweza kusimplify. Kwa tukisha simplify hapa, it means tutafungua mabano. Nimesoma kabisa kwenye topic ya algebra. The bracket, it means ilikuwa ni kufungua the way you can open the bracket. We have tried to see when we was at the O level, my dear students. Now we are supposed to take the number that are found outside here and multiply by each value that are found inside the bracket. Tutajaribu hivyo. Mwisho wa siku huyu gram ni common, atakansel na tutaweza kupata kumbe the center of the masses atakuwa ni sawa na negative 4i plus the 17 over 4j if we add by 7 divided by 4k. This should be. Baada ya kufungua hapo na